Professor, thank you for your kind introduction. Now, I would like to talk to you about recovery and reuse of the catalyst in cross-coupling reactions at ppm or catalyst loading. Palladium catalyzed bond-forming reactions are of great importance in organic synthesis, as there are many Nobel laureates. Typical reactions are shown here. As you can see, palladium is one of the most important metals in organic synthesis. However, despite these achievements, palladium as a catalyst has two main drawbacks. One is palladium is expensive, and the other is the toxicity of palladium. The cost of a palladium catalyst can represent a large proportion of the total cost of performing a reaction. The toxicity of palladium leads to problems in contamination of the final product, which is why cross-coupling reactions are normally not used in the final steps of a drug synthesis. Conventional reaction conditions involve catalyst loadings of several more %, which are far too high for practical use in the chemical industry. Therefore, one solution of these drawbacks is decreasing the catalyst loading. Reaching a level of 100 more ppm will remove the price of the catalyst from the reaction. And reaching 10 more ppm would remove the concern of toxicity. The catalyst loading used for the reaction being already at the same level than the requirement for palladium impurities in medicines. Until now, many examples with catalyst loadings at more ppm levels have been reported. And typical examples are shown here. In these typical reactions, Suzuki coupling reaction, Heck reaction, Sonogashira coupling reaction, the reaction using homogeneous catalysts and heterogeneous catalysts with more ppm catalyst loadings have been developed. Some examples with catalyst loadings at more ppb levels have been also reported. On the other hand, rhodium nanoparticles can easily be deposited on the PTFE surface of the magnetic starbar by stirring them in a rhodium nanoparticles ionic liquid dispersion at room temperature. And hydrogenation of benzene took place with rhodium nanoparticles on the surface of the magnetic starbar. Furthermore, Ananikov found that it should also pay attention to the metal species on the starbar. In the metal-free reaction and the reaction with catalyst loading at more ppm levels, because the Suzuki coupling reaction proceeds using the used starbar. We have reported that metal nanoparticles with uniform particle size are stabilized on hydrophobic polymers. When nanoparticles are generated in water in the presence of the polymer. In addition, when the mechanism of the reaction using these nanoparticles as a catalyst was investigated in the case of Suzuki coupling reaction, we confirmed that the metal species was dissolved from the surface of nanoparticles into the solution, and that this water-soluble metal species is catalytically active species. And it was confirmed that the water-soluble metal species was restabilized on the nanoparticles after the reaction. In the case of the Hirama coupling reaction, it was confirmed that the reaction proceeded alternately in water and on the surface of the nanoparticles. And in the Ullmann coupling reaction, the reaction proceeded only on the surface of the nanoparticles. Based on this background, we thought that it would be possible to reuse ppm level metal species by using a Starbar as a support. And the purpose of this study is to clarify the conditions under which metal nanoparticles on the Starbar can be reusable. These three types of reactions were used as model reactions in this study. First of all, to confirm the amount of palladium species on the Starbar, Suzuki coupling reaction was performed under these conditions. After the reaction, the Starbar was washed with GHU ether, water, and acetone in several times. And then the amount of palladium on the Starbar was confirmed to be 28 nanomole by ICP-OES analysis. To investigate the catalytic activity of Starbar, Suzuki coupling reaction of bromobenzene with 4-methylphenylboronic acid was performed under these reaction conditions. Because 25% of coupling product was obtained after the reaction, the Starbar was reused in 9 times. As you can see, although the yield varied, it was found that the Starbar could be reused. After 10th reaction, the amount of palladium on the Starbar was confirmed to be 14 nanomole, indicating the releasing of palladium species into the reaction medium occurred during the reaction, and that some of leached species remained in reaction medium. Interestingly, a similar study was carried out in these organic solvents with almost no coupling product being obtained in any case. In order to confirm the existence of palladium species, when the reaction was performed using the Starbar, after fifth run, 43% of coupling product was obtained. These results suggest that the reuse of palladium at ppm level is efficient only in the reaction in water. Because it is known that the amount of palladium leaching depends on base. The effect of base was investigated. The reaction didn't proceed efficiently in aqueous cesium carbonate solution, indicating the leaching of palladium species into reaction medium is important to proceed the reaction. We also performed Crabtree tests. When the benzene cyclooctatetraene, which inhibit homogeneous species, was added, the reaction didn't proceed at all. This result supports the reaction take place by homogeneous leached palladium species. Finally, we performed Hirama coupling reaction and Ullmann coupling reaction with used Starbar. Although the coupling product was obtained in Hirama coupling reaction, no reaction was confirmed in Ullmann coupling reaction. Considering Ullmann coupling reaction takes place on the catalyst surface, it is consistent with this result. In summary, when the Starbar was reused in Suzuki coupling reaction, although the yield varied, it was found that the product was obtained in the 10th reaction and the Starbar could be reused. The coupling product was not obtained at all in organic solvent, suggesting that the recovery and reuse of palladium at ppm level is efficient only in the reaction in water. Although Hirama coupling reaction took place with used Starbar, no coupling product was obtained from Ullmann coupling reaction. For the reaction with used Starbar, leaching of palladium species into the reaction medium, it seems to be important to proceed the reaction. Thank you for thank you very much for your kind attention.